Hello, we're going to start learning about inverse functions today. It's section 4.1 in the book. Before we start inverse functions, it's necessary to learn about one-to-one functions. A function is one-to-one function if a and for any a and b in the domain of the function. If a and b are two different numbers, then their images should be different also. That means if a is not equal to b, then f of a should also be not equal to b. Or we can say if f of a and f of b are equal to each other, that is only possible if they are the same number. A and b are equal to each other. So basically what we are saying in the simplest language, two different elements in domain will have different images in the range. Okay, let's see an example. The question is to figure out whether f, which is given as this set of pairs, a one-to-one function or not. So I always say I like to draw the function f is given from one set to the other set. 1 is related to 4, 2 is related to 3, negative 2 is related to 4. So what did we said the one-to-one definition was? Two different elements should not be related to the same element. If the elements are different, then their images should be different. But in this case, if you notice, 1 is related to 4 and negative 2 is also related to 4. So we are going to say f is not one-to-one function. Let's try G. G is from set A to set B. Let's name some random names for the sets. Negative 3 is related to 4. 1 is related to negative 1. 2 is related to 0. Now if you see here, every different element is related to a different image. So we will say G is a one-to-one function. What if the function is given to us graphically? Then we can use the horizontal line test for one-to-one functions. A function defined by y is equal to f of x is called one-to-one function if no horizontal line intersects the graph of the function in more than one point. So if a function is given in graphical form, how do you check it is one-to-one or not? We are saying no horizontal line should be there which is intersecting the graph in more than one point. So let's say we have some graphs here. We have to use the horizontal line test to determine if the graph is one-to-one or not. So this is blue graph. I've drawn this one horizontal line example here. This is intersecting the graph in more than one point. So we said no horizontal line should be there, so which intersects the graph in more than one point. So this is not one-to-one. So if you notice what's happening here, for negative 3 the image is 2, for 0 the image is 2, and for 2 the image is also 2. For different elements we are having the same image. That is why this is not one-to-one. Let's look at the second example. This blue one is the curve. If I draw any number of horizontal lines, none of them is meeting the graph in more than one point. They are only meeting the graph in one point. So this is one-to-one. This one here, this is not even function. Not function. Why? Because a vertical line is intersecting it in 2 points. So not function, so it cannot be one-to-one function. Okay, because of vertical line test. Okay, let's look at this last one. If I draw a horizontal line through here, it passes only one point. If I draw a horizontal line here, it passes only one point. So each of the point I'm intersecting, checking an horizontal line. They are not meeting in more than one point. So this is a one-to-one function. For a graph, has to be a function first to be a one-to-one function. For that, you have to check the vertical line test, meaning no vertical line should meet the graph in more than one point. For it to be one-to-one, it has to follow the horizontal line test, meaning if you draw any horizontal line in the curve, it should not meet the graph in more than one point. Now, we said if the function is given as a relation, how we check it is one-to-one or not. We determined how to check a graph, it is one-to-one or not. But now we have a function in the expression form, in the equation form. In part A here, y is given to be f of x, which is 2x minus 3. The question is to check if this is one-to-one or not. So the one basic way you can do that is plot it in the graph, right? Because we already talked about the graph. This graph has intercept at -3 and the slope of 2. So somewhere it will be looking like this, and this is a straight line. No horizontal line is passing through more than one point. So that looks like one way of saying that this is one-to-one. Other ways, you take any two points. Let's say f of x1 is equal to f of x2. Okay, so that means 2 times x1 minus 3 is equal to 2 times x2 minus 3. So we can solve the equation, subtract 3 on both sides. We will be having 2x1 is equal to 2x2. We can divide both sides by 2 and that will give us the x1 is equal to x2. That means whenever the images are same, then the variables are same too. That means that proves that the function is one-to-one function. Let's try part B. We have f of x is equal to x square plus 1. If you want to go to graphical method, you draw the graph of this function. It would be a parabola. We learned about quadratic functions before. Something like this. Okay. Now, if you draw a horizontal line, it's meeting the function in more than one point. So, this is not one-to-one by graphical. But let's try. Let's say I take x1 to be 1 and x2 to be -1. I'm taking two different points. So if f of x1 is 1 square plus 1, which is 2, f of -1 will be -1 square plus 1, which will be again 2. Now x1 is not equal to x2, but f of x1 is equal to f of x2. That means this function f is not one-to-one. Why? Because two different elements are there whose images are same. For one-to-one function, no two different elements image should be same. Let's define inverse function. Let f be inverse one-to-one function. So for defining inverse function, the function has to be one-to-one. That is most important. And g is the inverse of the function. Then following conditions are true. What is it saying? The compositions of f of g of x is coming back to the x. That means if you apply f and g both together on x, the answer comes back to x for all x in the domain of g. Or if you do g of f of x, it still comes to be x for all x in the domain of the function. So we are saying if we have a function f which is 1-to-1, then if there is a function g such that f of g is equal to x and g of f of x is equal to x for all the x in the f, then we say f and g are inverse of each other. Inverse of each other. Meaning we can also say that g is equal to f inverse. Now Remember, this negative 1 does not mean that g is equal to 1 of f. That is a wrong way of writing it. We cannot write it like that. It just is a terminology like that. G is equal to f inverse. That's how we pronounce it. Now, from that, we can also say if f of x is a function, f inverse is inverse of the function, then f of f inverse of x would be x by this given definition, and f inverse of f of x would be x again. Let's see it in an example. Question 4, part A. F of x is given to be 100 plus 12x. G of x is given to be x minus 100 by 12. We want to check if f and g are inverse of each other. What is the condition? F of g of x should be equal to x. Let's find f of g of x. So we always work inside out. So we have to write g of x first. Leave f as is. G of x is x minus 100 by 12. Now apply f on it. So 100 plus 12 times whatever was inside. That is x minus 100 by 12. We see that this can cancel. This can be simplified to 100 plus x minus 100. 100 can cancel, which is equal to x. And that is what we were expecting, right? Let's also try g of f of x. Of means brackets, g of, that means g is applied on f of x. So we write f of x first. In always work your composition inside out. Write f of x, that is 100 plus 12x. Now apply g on it. That means whatever this is has to be replaced by x. So that would be 100 plus 12x minus 100 divided by 12. 100 can cancel. That would look to be equal to 12x by 12. 12 can cancel, which is equal to x. So that is what we were expecting. So we say because f of g of x is equal to x and also g of f of x is equal to x, so f and g are inverse of each other.